Welcome to Cosmic Compass, where we explore the mysteries of the universe and uncover the stories hidden among the stars. Together, we'll travel through distant galaxies, strange planets, and cosmic wonders, always searching for answers to the biggest questions of space. Today, let's turn our attention to one of humanity's greatest tools of discovery, the Hubble Space Telescope. You may know it for its breathtaking images of faraway galaxies, but Hubble has also revealed incredible secrets much closer to home right here in our solar system. Let's take a journey through some of its most surprising and fascinating discoveries. For more than 3 decades, the Hubble Space Telescope has gazed deep into the cosmos, gifting us with breathtaking portraits of galaxies and nebulae far beyond our solar system. But here's something you might not expect. Hubble has also turned its gaze much closer to home. It has captured extraordinary events unfolding within our own neighbourhood, moments we would have missed without its watchful eye. In this journey, let's explore how Hubble expanded our understanding of the planets, moons, and mysteries within our solar system. Together, we'll uncover discoveries that reshaped how we see these worlds, sometimes in ways no spacecraft ever managed to do. Neptune is a planet that has been largely forgotten by exploration. Only one spacecraft, Voyager 2, ever flew by in 1989, leaving most of our knowledge limited to a brief encounter. If not for Hubble's patience and persistence, we would know even less. In 2013, Hubble revealed something remarkable: a tiny faint moon orbiting Neptune, now known as Hippocamp. It's not unusual for Hubble to spot new moons. It has discovered several around Jupiter and Saturn, but Hippocamp stands out. Measuring just about 35 kilometers across, it seems to be a fragment of Neptune's much larger moon Proteus. Proteus itself is scarred by massive craters, tens of kilometers wide. One ancient collision likely blasted pieces away, and from this chaos, Hippocamp was born. Today, it quietly circles near Proteus, a reminder of the violent past that shaped Neptune's system. When we think of moons, we often picture grand worlds like Titan or Europa, but Hippocamp teaches us something vital. Even the smallest fragments can carry stories of destruction and rebirth recorded in their very existence. Since 2015, Hubble has devoted regular time to Neptune, observing it roughly once a year. Why? Because Neptune's atmosphere is alive, with storms, massive vortices, thousands of kilometers across that form and vanish within just a few years. Voyager 2 once spotted the Great Dark Spot, a storm rivaling Jupiter's Great Red Spot, but unlike Jupiter's centuries-old storm, Neptune's vanished. Others soon followed, appearing drifting and eventually dissolving. In 2015, Hubble observed yet another such storm. It lasted a few years before slowly fading, leaving scientists to wonder about the forces at work. What could drive this restless weather? One idea is that Neptune's atmosphere, like Jupiter's, is divided into bands moving at different speeds. Where these currents meet, vortices can form, growing into massive storms. But once they drift away from their energy source, they weaken and die. What makes Hubble invaluable here is its unique ability to see Neptune in ultraviolet light, where these storms stand out clearly. Without it, much of Neptune's atmospheric drama would remain invisible to us. Now let's venture to the Kuiper Belt, billions of kilometers from the Sun. You might not have heard of 2007 Auroras, but it's actually the 3rd largest dwarf planet we know of, behind only Pluto and Eris. Hubble didn't discover this object itself, but it revealed something hidden about it. Scientists noticed that 2007 OR10 rotated unusually slowly, taking about 45 hours to complete a day. That hinted at an unseen gravitational tug. Searching through archived Hubble data, astronomers found the answer: a faint moon orbiting the dwarf planet. This discovery fits a broader pattern. Many Kuiper Belt objects have moons. Out there, collisions happen, at relatively low speeds so fragments can stay bound instead of flying away. Compare that with the asteroid belt, where impacts are so energetic that debris usually escapes into space. By studying systems like 2007 OR10, we refine our models of how the solar system formed and evolved. Each faint dot in Hubble's images carries weighty clues about our cosmic origins. Auroras are among Earth's most magical displays, shimmering near the poles when charged solar particles strike our atmosphere. But what about Jupiter in ultraviolet light? Hubble revealed auroras at Jupiter's poles that are unimaginably more powerful than Earth's, hundreds of times brighter, with a radiant power of around 100 terawatts. Unlike Earth's auroras, which come and go with solar storms, Jupiter's are continuous. In 2016, Hubble worked alongside NASA's Juno spacecraft. As Juno measured solar wind approaching Jupiter, Hubble tracked the auroras day after day. The findings were astonishing. Jupiter's auroras are not just fueled by the solar wind. Instead, they draw much of their energy from charged particles trapped in Jupiter's intense radiation belts. These particles stream along magnetic field lines, colliding with the upper atmosphere and igniting an endless glow. Even more fascinating scientists discovered that Jupiter's magnetic field drives alternating currents, not the steady direct currents once assumed. That alternating power helps explain how such enormous energy flows into the auroras. When you imagine standing beneath Jupiter's skies, remember this: above the poles, curtains of light blaze without end, a ceaseless reminder of the planet's immense power. Europa, one of Jupiter's largest moons, has long intrigued scientists. Its icy surface hides something extraordinary, an ocean of liquid water beneath, warmed by tidal flexing from Jupiter's gravity. If there is anywhere beyond Earth where life could exist, Europa may be the place. Hubble surprisingly has played a key role in this mystery. By observing in ultraviolet light, it detected plumes of water erupting through cracks in the ice. Volcanic-like activity suggests that Europa's ocean is not only liquid, but dynamic, connected to the interior through vents. But there's more. Hubble also identified sodium chloride, ordinary table salt, across Europa's surface. This salt likely originated from the subsurface ocean and was carried upward by the plumes. Why is this important? Because salty oceans on Earth, especially around hydrothermal vents, teem with life. Imagine standing on Europa's frozen plains. Beneath your feet, a vast ocean churns in darkness, possibly with its own ecosystems. Plumes erupt skyward, sprinkling the surface with sea salt, and somewhere in that alien sea could life be stirring? Hubble cannot answer that question, but it keeps the dream alive. Uranus is a planet full of oddities. Its axis is tilted so dramatically that it rolls along its orbit sideways. Unlike any other planet, this tilt shapes its seasons, which last decades, and creates strange opportunities for observation. In 2006, for the first time, Hubble caught the shadow of Uranus's moon, Ariel, crossing the planet's disk, a rare eclipse event. The last time this could have been seen was in 1965, long before telescopes were advanced enough to capture it. Hubble has also revealed storms in Uranus's atmosphere and even auroras near its magnetic poles. Strangely, those poles don't line up with the planet's rotation, adding another layer of mystery. Seasonal changes have also been observed. As a pole tilts toward the sun, the atmosphere brightens, forming a massive cloud cap. When the seasons shift again, the cap fades. Yet, with Uranus taking 84 Earth years to orbit the Sun, Hubble has only watched a small fraction of its year so far. There is still much to discover about this sideways world. Through these stories, Hippocamp's quiet orbit, Neptune's vanishing storms, hidden moons of dwarf planets, Jupiter's eternal auroras, Europa's ocean plumes, and Uranus's tilted seasons, we see that Hubble is more than just a cosmic camera. It is a vigilant guardian of our solar system, catching fleeting moments that no spacecraft has witnessed. Hubble has been orbiting for over 30 years, and it may continue for another decade or two. While the James Webb Space Telescope now extends our reach even further, Hubble's legacy is secure. It has shown us both the grandeur of the distant universe and the wonders close to home. As we look forward, let's remember what Hubble has given us, not just data, but perspective. Each discovery reminds us that we are explorers peering outward from our small blue world, forever curious about what lies beyond. And perhaps the next great revelation is already waiting, hidden in the light of a star, a planet, or a moon, until Hubble or its successors show it to us. This has been another journey with Cosmic Compass. As we've seen, the Hubble Space Telescope continues to expand our vision of the cosmos, capturing wonders both near and far. Its discoveries remind us that exploration is never finished. There is always more to uncover, more to understand. If you enjoyed this exploration, don't forget to join us for future voyages into space by subscribing and sharing this journey with others who love the stars. And as always, keep looking up, because the universe still has countless stories waiting for us to tell.